Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you not like the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. So problem is minimize deviation in array. We'll be given an array of n positive integers. So if you see the input, there is an array given and it has n integers and those all will be positive. You can perform two operations on any element of the array, any number of times. So this operation we can perform on uh, any element in the array any number of times. If the element is even, we can divide it by 2. So 4 is even, 2 is even, we can divide by 2. For example, here array is what? 1, 2, 3, 4. You can do this operation on the last element. Last element is 4, na, which is even. So we can divide it by 2. So 4 divided by 2 will be 2. So array will change to, here 2 will come. And if the element is odd, for example, in this array, we have 1. 1 is odd. So what we can do, we can multiply it by 2. So 1 into 2 will be 2. So this here, then 2 will come. And rest of the array as such. So right, we can do these operations. If the element is even, we can divide it by 2. And if the element is odd, we can multiply it by 2. The deviation of the array is the difference, maximum difference between two elements in the array. That is maximum difference between two elements. We need to return the minimum deviation that can in the array after performing these operations. For example, we need to reduce this deviation. The difference between two elements we need to reduce it as much as we can. And that reduced deviation we need to return. So let's see this example. This is test case given, right? Let's understand what the problem is first. So we need to, in the output, we have to return minimum deviation. Minimum deviation. What is deviation? Deviation is the difference. Difference between, it's the deviation is, see, deviation is the maximum difference. Max difference between two elements. Now, obviously, see guys, what will be the maximum difference between two elements in an array? If we take the smallest number and if we take the largest number, that is largest number minus smallest number will be the maximum difference between two elements. This is so easy, right? Like what will be the maximum difference? We take the maximum number, we take the minimum number, we subtract them and that will be the maximum difference. So here maximum difference is 19. This is the deviation. This is deviation. We need to reduce this deviation. We need to minimize it. Minimum deviation. That means, see, when we are saying that we need to reduce this value, 20 minus 1 is equal to 19. We need to reduce this 19. Minimum deviation. So how that can happen? We are subtracting maximum and minimum, right? How we can reduce this value? There are two things which we can do. Either we can do these things, like see, either we can decrease this maximum value, we decrease the maximum and we increase the minimum, right? So like if we decrease maximum, let's say 20 is 10, it's changed to 10, and this 1 is increased, it's increased to let's say 5 or 6. So now see, difference will come less, na? So we need to return minimum deviation, that is we need to reduce this 19, this value, deviation value. So for that we have to decrease the maximum element, the value of the maximum element we need to reduce, and the minimum element value we have to increase so that the difference is reduced, right? This will be the approach. Now how to execute this thing, how to apply these operations, because see how we have to reduce these values, this maximum value, this minimum value, We have to reduce the maximum and we need to increase the minimum. But how we will do that? There are certain rules. We can only do these two operations. All right, so see, here what we have, here we have maximum value as 20. This is the max, and minimum is 1 in the array. So over here they have written that if element is even, we can divide it. So we can divide this 20 because this is even. So this is even, right? 20 is even. We can divide it by 2. So then we get 10. Then again this is even. This is even now. So again we can divide it. So 10 divided by 2 will get 5. Now we cannot divide because 5 is odd. We cannot divide 5. And see, there is no point in multiplying also because we are reducing from 10 to 5 na. Why to multiply again? We were already at 10. So there is no point of multiplying, right? Again. So we not multiply. We'll just stop here. So from even number, see, from this even number, we reach to the odd number. Then we stopped. When we reach to the odd, we stopped because we cannot divide by 2 because divide by 2 only we can do for even. And multiplying by 2 doesn't make any sense because we were earlier at 10 only. So why to again go to 10? Alright, this is one thing. For this minimum, this is odd. This is odd number, na? So odd number we can multiply by 2. So let's do that because we need to increase the odd. Increase the minimum number. Na? So we'll multiply it. 1 into 2. This will be 2. Because this is odd. This is odd. That's why we are multiplying. Right? If let's say here it was 2. The minimum element in the array was 2. Then we will not able to multiply because this is even number. We can only divide by 2 even numbers. We cannot multiply. So here if 2 was there, we cannot multiply it by 2. Here minimum is odd. It is 1. That's why we are multiplying by 2, right? So don't get confused on that. So we multiply this 1 by 2 because we want to increase the value of minimum. Na? So that's why we are multiplying it. So now we get 2. Now we have to stop here because now we cannot, see, now we cannot do anything. Na? Here we cannot do anything. This is even. So for even either we can divide. So but why to divide? We were already at 1. So if we divide it, we again go to 1. That doesn't make any sense, right? So see guys, now from this you will see something. See, if you look closely, this 1, if your minimum element which is given in the array is odd number, here it was 1. If you multiply it by 2, because odd number we can multiply by 2. If you multiply by 2, you will be thinking why we are multiplying, because we need to increase the value of minimum so that this deviation is decreased, right? If we multiply it by 2, it becomes even. Any number, any odd number, 3, 5, 7, once you multiply it by 2, it will become even number. So you can only multiply once. You can only multiply once any odd number by 2. So this multiplication operation can only be done once on the odd numbers. I hope you are getting my point. See, this multiplication operation can only be done once on all the odd numbers. So let's do one thing. We have this array 4, 2, 5, 23. We have this array 4, 2, 5, 23. So we concluded that only once we can multiply all odd numbers by 2, because once they are multiplied by 2 they become even. So then we cannot multiply again, and obviously there is no point in dividing because then it will reach back to its original number. So see what we will do first step 1, we will multiply all numbers once, because once only we can do. We just saw that. Multiply all, what we are doing over here is multiplying all odd numbers by 2. This is first step. So let's do that. Basically what we are trying to do now, we are trying to reduce the max element as low as possible. We will do by dividing it by 2 if it is even, and we are trying to increase the value of minimum so that deviation is reduced. We need to reduce the minimum deviation, right? This is what we are doing. So now we will see the dry run of this approach. So first step what we are doing, we are multiplying all odd numbers by 2. So here 4 is will be as such, it's not odd. Also here it was 1. Na? I by mistakenly written it. In the test case here it was 1. 4, 1, 5, 23. So here 1 will come. So this odd number will get multiplied by 2. So 1 into 2 will be 2. See, now it is even. Na? Now 5 is also odd. 5 into 2 it will be 10. 20 is even as such, and 3 is also odd. So 3 into 2 6. So this first step is done. Multiplying by all odd numbers by 2. So this is one step we have done. All the this odd thing we are done with this. Now we can use this second operation. Second operation was if the element is even divided by 2. So now we will reduce the even elements so that difference is reduced. So second step will be what? We will do, see, we will, what we will now try to do. See, this is kind of, you need to understand what we will do now. So see, right now the minimum in this array is 2. Minimum is 2, right? Maximum is 20. Max is 20. Max is 20 and difference is 18. Difference is 18. 20 minus 2, 18. 20 minus 2. Now we need to reduce this difference. So max we need to decrease. This 2 cannot be increased further because this is even. Either we can divide it or we do nothing, right? So dividing doesn't make any sense. It will again come to 1. So that we do not want to do. So this is the maximum minimum that can be possible, right? As of now. Now maximum is 20. We need to decrease this. So what we will do, we will divide this 20 by 2. So let's do one thing. Every time we will have to find na that what is the maximum element in this array. We have to traverse every time. Let's avoid that. We can have a data structure that every time that will give us the maximum element which is in the array. So for that, I hope you guessed it, we will be using a max heap. We use a max heap. So max heap give us the maximum element every time. So earlier na, when we were multiplying all the odd numbers by 2, as we will be multiplying na, like we multiplied 4 will be as such, so we will push it in the max heap. Then we get 1 into 2, we get 2, so 2 we will push in the max heap. So like when we were multiplying na, then at that step only we can also push in the max heap. So here 10 will be pushed, 20 and 6. So this will be your max heap. Right? Now see, what we have to do. We will pop out the maximum element from this max heap. 20 will be popped out. 20 is the maximum. We can store it in a variable 20. Now what we will do? We will find the difference. Let's find the difference. This is the maximum element. 20 minus 2, 18. So 18 is the right now the difference. Now what we can do is, this is even number. This is even. So we can reduce it by, we can divide it by 20 divided by 2. So this will become 10. So now we can push this 10 in the max heap. Because now this 20 here. This 20 is reduced to what? 10. We divided it by 2. So 10 we will push in the max heap. 10. So see guys, what we did in the second step, we popped max element from heap, right? We found out the difference. Difference will be minimum of the current difference, which is the current difference, and this element which is popped minus the minimum element. This will be the difference. All right. So then after that what we will be doing is we will reduce this element by 2 and we will push in the max heap again. Push in max heap because now it's reduced, 20 is reduced to 10. So we'll add it in the max heap. Push in max heap. Also we just need to check whether this mx by 2, this new element 10, if it is less than this minimum. Because if this is less than this minimum, then that will be the new minimum. Na? So we will just check whether the current minimum should be is like minimum of current minimum and this mx by 2. Right now 10 is not minimum, so 2 will be the minimum only. Now let's again do this. So what we will do is again, see, I know it's a bit of complicated, but when you will try run, you will understand, don't worry. So now we will again pop max element from heap. 10 will be popped. So there are two 10s. So first this, let's say this 10 is popped. 10 is popped. Alright. Now we will find the difference. 10 difference will change. Now difference will be, this is the maximum element right now. See, right now this is the maximum element in the array. So 10 minus, difference is 10 minus the minimum, which is 2. So difference is right now 8. Difference is right now 8. This is the answer, like this is the output which we will return. This will be the, this we have to make it minimum. Alright. So difference we have done, then we will divide this by 2. So 10 by 2. See, this is even, na? So that's why we are dividing it by 2. 10 is even. So 10 by 2, 5. And we push it in the max heap. So 5 is pushed in the max heap. 5. Alright. And then what we do is, so this 10 is now again changed to 5. Okay. Now we will be calculating the minimum. So minimum, this is 5 and 5 is not less than 2. So minimum will be this only. Now again, same steps. We will pop from the pop a maximum element from the heap. So what is the maximum element? Maximum element is 10. 10 will be popped. And difference will be again 10 minus 2. So it will be 8 only. Nothing will change. And push it again in the max heap. So 10 divided by 2, 5. So 5 will be pushed in the max heap. Here 5 will be there. 5. So 5. Right. And then this minimum will be 2 only. Now again same steps. So now again max will be popped from the max heap. So you will be thinking till how long we will do these same steps again. You'll understand, right? We'll get to that. Let's do it again. So now maximum is 6. So 6 will be popped. 6 will be popped. And we will find the difference. So 6 minus 2. 6 minus 2. 6 minus 2 is what? 6 minus 2 is 4. So minimum is 4. Sorry, difference is 4 now. And we will divide it by 2. So this is 3. And we push it in the max heap. So this is 3. Here, this is now changed to 3. Alright. And then minimum will be 3. So 3 and 2. Minimum is 2 only. So minimum will not change. Now see. Now again, same steps. Maximum will be pushed from popped from the this max heap. So now maximum is 5. Now guys, see, is there any benefit of doing all these steps now? Why no benefit? Because this 5 is odd. We cannot divide it by 2. So we cannot decrease further. This is the maximum element that can be now. We cannot divide it further by 2. This is odd element. So either we can increase its value by multiplying it by 2 or we do not do anything. So see, we need to decrease the maximum value, and this could be the lowest possible maximum value. Now it could not be reduced further. So these steps we will do until the popped element from the max heap is even. Until the popped element is even, we will continue continue doing these steps. Popped element is even until once the popped element is odd, this was odd, then we can stop, because this now further cannot be reduced. We cannot do mx by 2 for this. This is odd. Now see, we will come out of the loop, and at last the difference will be maximum is 5. That is, we will pop from the max heap the maximum element 5 minus the minimum, which is 2. So the difference, which is 3, this is the minimum deviation. This is the difference which could be, and this is the minimum difference. So 5 minus 3, the maximum element minus the minimum element. So this is how we will approach this problem. I hope you got some idea. This is, see, earlier what we did na, we first of all got to know that this operation, multiplying by 2 1, this can be only done once to all odd numbers, and we have to increase the value of the minimum, so that's why we are multiplying. And then this division we can do to decrease the maximum value. Alright, so try to dry run this on other test cases also, this approach. So I hope you understood. Let's see the code once for this. So see, first of all, so we are creating this max heap. So this is, I have taken this max heap. This is max heap priority queue, and then this m is the minimum element, this thing which we have taken, and this difference also I am taking. So both should be minimum na. So I am initializing them with the maximum value which could be there. So this difference also should be minimum, and this minimum also should be minimum. So initializing it with int max, int max. Then first step what we are doing is we are multiplying all the odd numbers by 2. So here we are going to each element in the vector in the nums array, and if they are odd, then we are multiplying them by 2, finding the minimum every time, because like when we go to each element na, so we will be finding the minimum also along with it. So minimum 2 will come. Alright, and side by side we are pushing them also in the max heap. So we discussed that, right? When we will be multiplying odd numbers by 2, like 1 into 2 here, 5 into 10 was here na, so like that, then we will be also adding it in the max heap. So this is done. After this is the second step. Now second step, we will pop until the number is even. So keep doing this until number is even. That is the top element on the priority queue max heap is the even number. And what we are doing, see these steps: pop from the stack, max heap, we are popping. Then we are finding the difference between this element which is popped and the minimum element. This m is the minimum. We are finding the difference, and then see, finding the difference, and then what we were doing, we were pushing in the max heap, and we were mx by 2, and we were calculating the minimum, whether this mx by 2 is the minimum element. So these two steps, pushing in the max heap, finding the minimum, like updating the minimum, you can say. After this, see, when mx was 5, so now this while loop will not run, this code will not run. So once we got a odd element on the top of the max heap, then we come out of the while loop, and then we find the minimum difference, the current difference, what is the current difference, and the top element. The top element was what, 5 na, 5 minus the minimum, which was 2. So 5 minus 2, which is 3. So what is the current difference, and this thing, like whichever is minimum, that we will return. Alright, so this is the code. I hope you understood the code. And I hope you understood the approach also. Let me know in the comments if you have any doubt, and if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.